This is Mrs. O'Neill for AP Chemistry, Chapter 10, Section 3, the gas laws. Most of this should be review from your Chemistry 1. So the objective for this section is to classify that the state of a gas can be expressed in the terms of its volume, pressure, temperature, and quantity, and examine several gas laws, which are relationships among these four variables. So not only do you need to understand the unit of volume and pressure, you need to understand when volume goes up, what happens to pressure? Does it go up or down? That's the relationship between the two. Please pause the video, fill in the blanks, and then play to hear my words. Boyle's law, which you should have heard of before, deals with pressure and volume, meaning that everything else is constant, especially temperature. And they have an inverse relationship, means they have an inverse proportion to each other, which means they do the opposite. So pressure and volume do the opposite. So if pressure goes up, volume goes down. And I want you to take notice of the equation, pressure times volume. So the ones are your initial pressure and volume values, and then the twos would be like your final pressure and volume values, okay? But they are multiplied with each other, and they have an opposite relationship to each other. Charles' law, on the other hand, deals with temperature and volume. Pressure is constant as well as everything else, and they have a direct proportion to each other. In other words, they do the same. So let's look at the equation. Again, you have your initial, but now they're divided by each other instead of multiplied. So you have volume 1 divided by your temperature 1, or your initial volume divided by temperature equals your end result, or your final volume and temperature. And another thing we want to keep in mind is all temperatures must be in the Kelvin unit. This is on your reference sheet, so you're just going to take the degrees Celsius that they give you value plus 273. Now this is something I'll, especially for this particular section, I will constantly remind you of that, but later on in other sections it's just going to be automatic. Anytime you see gas law problem and you see a temperature, you're going to automatically change it to Kelvin by adding 273. Avogadro's law, which you might have or might not have heard of in Chem 1, deals with volume and N represents the number of moles. And again, notice that it's volume divided by N, so that should give you the direct proportion. Ding, ding, ding. That means they do the same again. So as volume increases, the number of moles is going to increase. So we want to remember that equal volumes of gases contain equal number of molecules. And what does this mean? Well, there's that 22.4 liters. Remember, every time we did a mole island problem going from liters of gas to moles, we always did 22.4. It didn't matter what gas it was. It could have been argon as an element, or it could have been carbon dioxide as a compound. We always said that if we had 1 mole of that substance, we would have 22.4 liters. And that's what this law really represents. So equal volumes of gas at the same temperature and pressure contain equal numbers of molecules, or equal numbers of moles. In other words, if I took this container and they both have exactly the same volume, it doesn't matter what gas I put in there, I would have 22.4 liters. I would have 1 mole of molecules no matter what substance it is. Gay-Lussac, you might not have heard of him either. He says there's a law of combining volumes. So at constant temperature and pressure, the volumes of gases involved in a chemical reaction are in whole small numbers. The ratios are in small whole numbers. Jeez. So what does that mean? Well, think about stoichiometry. So remember, when we had a 2, a 1, and a 2 for our coefficients, we always say 2 moles of hydrogen plus 1 mole of oxygen yields 2 moles of water. Well, we can also say 2 volumes of hydrogen. So 2 times 22.4 plus 1 volume of oxygen, 22.4, equals 2 volumes of water, which would be 2 times 22.4. So you can also use that relationship with that 22.4 liter volume. So now what I suggest is getting out a separate piece of paper to do these gas law problems. I also suggest pausing the video, do the problems. Now you can do them one at a time and then play the video to see the answers and solutions, or you can do the problems all at once and then go through all of the video at the end. So it's up to you. I want to remind you that temperature always has to be in the Kelvin unit, and I'm going to show you the problem step by step. So this way, if you get to a point in the problem and you're like, what do I do next? You can play the video, you can see the step by step, and maybe you might want to pause it and go, oh yeah, that's how you do it, and then continue doing the problem, and then go back to playing the video to see if you get the right answer. So that's how I'm going to do all of these problems. I believe it's this section and the next 2 or 3 that you're going to be doing a lot of gas law problems. And I just want you to see how the step-by-step process works. And it's easy to start with this section because you've done these gas law problems again in Chem 1. So these should be just review. So here's number 1. If I write out all the information, I'm dealing with pressure and volume. And notice I'm going to change my torrs to atmospheres right away because it asks me for the pressure in atmospheres. So I'm going to use that equation. I'm going to rearrange it. I'm going to plug and chug, and I'm going to get an answer of 20.0 atmospheres. And again, I tried to do it by sig figs. However, nope, this one seems to be working. 3 sig figs, 3 sig figs. This is 4 sig figs, so my answer should be 3 sig figs. Number 2, I'm going to write the information. I have temperature, so right away I'm going to change it to the Kelvin unit. I'm going to then take my equation. I'm going to rearrange it. I'm going to plug and chug my numbers, and I'm going to get an answer of 0.0200 liters. Again, that's 3 sig figs. So if we look here, we have 3 sig figs for liters. Now again, when we're dealing with temperature, degrees Celsius changes to Kelvin, and that goes from 2 sig figs to 3 sig figs. We're going to hold on to the 3 sig figs because we have to do it in Kelvin unit. Okay? Number 3. Ooh, grams. When they give us grams, guys, go right to moles. You will never see a gas law problem that necessarily deals with grams. You are going to most likely have to change those to moles right away. So using the formula weight of oxygen, which is 32, right, because oxygen is O2. So if you got that wrong right from the beginning, check that work and go back and then rework the problem. So again, we're going to take our equation, we're going to rearrange it, we're going to plug and chug, and 10.8 liters. And again, don't forget your units at the end. Sometimes they ask for it and sometimes they don't care. So if you remember, just, I know us science teachers are always harping on the liters, so keep going with that. Number 4, this is the combined gas law equation that you learned in Chem 1, so you didn't get it here, but you probably or hopefully should be able to combine the Boyle's and Charles law. So here's all the information, and right away I changed my temperature to Kelvin. I'm going to take my Boyle's and Charles law and combine it. I like to keep it this way instead of dividing it by the T2. If you have P1V1 divided by T2, it gets a little crazy to kind of rearrange everything. So I rearrange it first this way, and then it's easy to rearrange whatever I want. And in this case, I want V2. So I'm going to rearrange. I'm going to plug and chug. And now this one, again, I'm going to remind you, if you're plugging and chugging right into the calculator, that's fine, but be careful with this bottom. 725 times 273. So do the top, 755 times 1.62 times 323 equals, divide, parentheses, 725 times 273, parentheses, equals. If you're unsure about that, please ask me or somebody else that you feel comfortable talking to make sure you're understanding and doing the math right. If you're not that math savvy or calculator savvy, cheat. Do the top 3 numbers, multiply, get a number, write it down. Take the bottom 2 numbers and multiply, get a number, and then do the division. So do the multiplication on the top, do the multiplication on the bottom, and then do the division, and to make sure that you get the right answer. And your answer is 1.996. But if we look up here, that's going to be 3 sig figs. Your temperatures are 3 sig figs. Your pressure is 3 sig figs. So we actually need to round this to 2.00 liters to get that 3 sig figs. All right, that's the end. Hopefully you can do those problems. If not, please try working them out again. These are your easiest problems of the whole chapter. So if you can't get these, the other ones are going to be real difficult. So make sure that you have these down pat. Okay, see you in class for any questions.